Good day, everyone. Thank you for joining the Docker IT for Systems Admin webinar featuring Mike Coleman, Technology Evangelist. A few housekeeping items before we get started. As a reminder, this session is being recorded, and a copy of the recording will be sent out a couple days after the webinar. We will take questions, so please type them in the Q&A window located in the lower right-hand corner of your screen as they come up, and Mike will address these questions. I will now turn things over to our speaker, Mike Coleman.
Hey there, everybody. Thanks a lot for joining this morning. My name is Mike Coleman. I am going to take you through kind of this, I'm sharing my screen. Give me a second. Here we go. And then we go with this. You guys should see my slides now. So I'm going to take you through Docker, but I'm a sysadmin. So that the title's kind of funny, but it comes from experiences that I've had talking to people and being in the sysadmin space, and they're like, Docker, that's for developers. I'm a sysadmin. And then one day, somebody walks into their office and says, hey, by the way, here's the new application. We did it in Docker. Have a nice day. And so you're left in this position where you're wondering, where do I go from here? And how do I think about containers in respects to how I already manage my data center, how I already manage my workloads? So we're gonna talk a little bit about that today. Before we get started there, though, let me tell you about who I am and how I got here. So the first half of my career, I actually was a sysadmin. This was a long time ago. I was a certified Banyan engineer. I was an MCSE, Microsoft Certified Systems Engineer on Windows NT 3.1, and I was a Novell Certified Netware Engineer on Netware 4.0, all those at the same time. So I did a lot of networking, a lot of server admin, then moved into HP, UX, and then Unix and Linux systems, working for companies like Intel and HP. So some pretty big companies. Around, I don't know, a while ago, I moved into product management, product marketing. And I started at Microsoft, where I worked on a bunch of versions of Windows, starting with Windows XP. From there, I moved over to VMware. I spent 6 years doing virtualization. So I was at VMware in 2008 when it was only a couple thousand people, and it wasn't vSphere yet. It was still ESX. And then went from VMware into the open source world by working for Puppet Labs, or as they're called now, Puppet, as a product manager working on infrastructure deployment tools. So how to use Puppet to roll out VMware, how to use Puppet to roll out Docker, how to use Puppet to roll out AWS. And then I joined Docker. It's almost exactly 2 years to the day. I joined on July 8th of 2015, so almost exactly 2 years. So you can see from my background, I'm definitely more of an IT pro than a developer. I can write a little bit of code, but I'm not a professional software developer. I've never been a professional software developer. And if you want to follow me on Twitter, you can get me at Mike G. Coleman. But most of the time, I tweet about Portland Timbers, which are the local soccer team. I live up here in Portland. So we're going to jump into this, and we're going to approach containers from a point that most of us probably already understand, which is a virtual machine. And I will start out by saying containers are not VMs. When I first started talking to people about Docker, and even still a little bit today, people would say, oh, it's lightweight virtualization. It's just like VMs, only it's lightweight. Well, it is lightweight, and so it's an easy connection to make, right? Because if you think about a container and a virtual machine, they're both these binary units, like they're a thing, man, of X's and O's, or zeros and ones, and you can move it around, right? So it's this piece of binary information that can be moved from server to server and isolates something and gives you some portability. So that's what VMs and containers sort of do at the most fundamental level. So, but what goes on behind the scenes is completely different, and what the use cases are completely different, right? Virtual machines really are about infrastructure, and they're about optimizing that infrastructure. They're about getting and deploying and not having to worry about underlying hardware so much, and being able to kind of abstract that up and get some isolation and better resource utilization. Where containers are more about doing that for the application, right? You think about optimizing infrastructure, we're about optimizing VMs, right? We're about optimizing the things that you deploy VMs for. Nobody deploys a VM just to deploy Windows, typically, right? They deploy it to deploy an application that runs in Windows or an application that runs in Linux. Well, we want to make those applications better, right? And that's what we're about. So we'll start, you'll start seeing a separation between like the application and the virtual machine, where today those things are inextricably linked, really. And that's what we want to sort of shift people. So how are they different? How are they the same? We'll set some context. Virtual machines are like houses, right? If you think about a house, it's fully self-contained. It's got its own heating, its own plumbing, its own air conditioning, right? It's got a front door that locks so people can't just walk into it. If my family outgrew my house and I needed to build another house, I would build a completely separate structure, and it would have its own heating, its own plumbing, its own air conditioning. It could be exactly the same as my house that I live in now, but we would replicate everything. So that's virtual machines, right? So virtual machines are a full copy of the operating system. They have isolation around them to prevent people from coming across and intruding into that operating system. But if I want to create a new instance of a VM, I stand up a full replica of that VM image, right? So a full copy of the operating system, a full copy of the application, everything, right? It has its own plumbing, its own heating, its own air conditioning, its own memory, its own CPU, its own whatever. That's sort of VM, right? So think about them a little bit monolithic, a little bit larger, right? Like you can only get a house that's so small. The first house I bought was like 800 square feet. It was 2 bedrooms, a living area, a kitchen, and 1 bathroom, and a laundry room, right? And so, and if you think about VMs, they're only going to get so small, right? Most VMs are going to be in the orders of magnitudes of gigabytes, but you'll get some that might be hundreds of megabytes, but that's getting down there. And that also translates into a little bit of performance, in as much as VMs typically take on the order of several minutes to start up, right? Well, anywhere from a few minutes to several minutes. You can boot a VM in 3 to 4 minutes, but it can also take 15 minutes, depending on what's running on there. So that is, the virtual machine context, which you're all familiar with, I'm sure. Containers, how are they different? Well, containers are like apartments in an apartment building. So think about the apartment building itself as the Docker host, right? And the Docker host is any computer. So it could be a virtual machine, it could be a cloud instance, an EC2 instance, an Azure VM, DigitalOcean, Google, doesn't matter, or it could be physical hardware, right? Could be a large Cisco UCS system, it could be an HP DL350 or whatever the latest model is, or it could be a Raspberry Pi, right, sitting on your desk. Any one of those compute resources will run something called the Docker engine. And the Docker engine isn't a hypervisor. If you think of the way the hypervisor works, the hypervisor is like a circuit breaker for your electrical system, in as much as that all your electricity has to pass through the circuit breakers, right, in your house. Whereas, the circuit breakers have some control over that, and that's what the hypervisor, right? The hypervisor sits between your application, between your virtual machine, and the underlying hardware. You issue a command, it's interpreted by a virtual CPU that gets passed to a hypervisor that gets sent over to a physical CPU, right? There's some cases where there's direct hardware access, of course, but for most part, they use the hypervisor. The Docker engine, on the other hand, actually is more like a doorman at an apartment building. It basically directs traffic. It tells you what floor to go to. It helps you move in. It helps you move out when you get your new apartment. That's what the Docker engine does. It starts containers. It stops containers. It lets you list containers. It basically sort of deals with the life cycle of the container. But once the container is running, it's just a process. running in the operating system. And that's the other big difference. The reason I say it's an apartment building is that apartments in an apartment building share common infrastructure. They all share heating, plumbing, and air conditioning. They share an elevator. Well, with Docker containers, they share the kernel of that operating system. All the containers do. That means in a Docker host, whatever the OS for the host is, that's the OS for all your containers. So a Linux Docker host runs Linux containers. A Windows Docker host runs Windows containers, right? Now, it doesn't have to be the same version of that operating system. It just has to be the same family. So you can have a Linux host that is, Ubuntu, and you can run a Debian container, a RHEL container, a CentOS container, a Slackware container, because all we're using in the case of Linux is that kernel. So you've got the right kernel version, which is Linux kernel greater than 3.1. You can put the Docker engine on it, and you can run Linux versions, any Linux version you want in a container, pretty much. So a couple other things. That means containers can be really small and really fast. I'll do a couple demos today where my application's running in my container at about 30 megabytes. There was a contest on Twitter, and someone said, make the smallest container that would start up, print hello world, and exit. And it was 64 kilobits, right? Certainly, containers can be much larger than that. They can be as large as VMs, but they can also be much smaller. And regardless of the size, because the container is based on the operating system that's already running on the Docker host, when you start a container, you're just starting a process. It literally takes about a third of a second for a container to start up, right? So if you think about scaling out a lot of containers, I can boot 100 containers in like 10 seconds. If you want to boot 100 VMs, that's going to take you a little while to do. But just because they're different doesn't mean they're mutually exclusive, right? So a lot of customers run, like you see on the right, they run their containers inside a virtual machine. There's a lot of good reasons to do this. That's why people do it, right? So on the left, or on the right there, you may have in the first Docker engine, you may have the, right here, sorry, getting this. So you may have, you may have on the left Docker engine there, you're running a Linux virtual machine, you got containers A and B running in there, and they're running alongside a Windows virtual machine, and it's running application C, and then application D is just sort of a traditional monolithic VM, right, running some other application. Those applications, those VMs can talk to each other. Those containers can use the virtual machine network to talk to each other if they need to. Maybe app D is the database, right? And app A and app B are some Linux web front ends, and app C is some business logic. And all of those things work together. That's totally fine. You do this because you want to run Windows and Linux workloads in containers on the same bare metal hardware. By putting them in VMs, you can do that. Now, only Linux containers in the Linux VM and Windows containers in the Windows VM, but this helps you drive utilization. It also lets you make sure that you're leveraging your existing skill sets, right? And it lets you make sure you're protecting your existing investment. There's absolutely nothing wrong, and matter of fact, there's several good advantages to running containers inside of VMs. And by using containers, you can actually become more efficient with those virtual machines, and we'll talk about that a little bit later. But some people want to run bare metal, and that's totally reasonable too. Most of the time, this is about performance, right? They want to get every last bit of lag out of the system, and so they want to go bare metal. Almost everybody will universally agree that bare metal performs better than virtualized workloads, and it's not, it's not every workload, but a good percentage of them, and it's because you're removing that hypervisor layer, right? And so you can do that. So people who are really intent on costs, right, or on performance, they may go with bare metal, and we see a lot of customers doing that, right? It simplifies the stack a little bit for them, removes one more component to manage. So we talked a little bit about some trade-offs between containers and virtual machines, but there's a lot of things to consider, right? Because if people come up to me and they'll say, right, the number one question is, you know, how's a container different than a VM that I sort of get? The number two, you know, or what is a container, right? Those sort of two questions go hand in hand. The next is, where should I run my workloads? Like, where should I actually put my work? And that's a really interesting question because I don't have an answer for it. There's a lot of variables to consider, right? What do you value the most? Is it performance? Is it scalability? Those sort of go hand in hand, and they are directly reflecting on the costs, right? Well, what about security? Well, so from a most basic level, containers are isolated just like VMs, right? I mean, they're not using the same technology, but they have that same sort of isolation where you're like, I can't just walk into a container, right? I can't just, you know, SSH into a container, right? There's some isolation there using Linux technologies and Windows technologies to protect that workload. But there's a lot more to security than just isolation. Isolation is the bare minimum you need to think about. That's table stakes, and we have that in spades. But there's a lot of other things to think about. We'll talk about some of that as we go down the slides here. Existing skill sets. What are you good at, and what do you want to stay focused on? Right? You don't want to throw the baby out with the bathwater as you move into containers, right? You want to be able to preserve existing skill sets and leverage them while you take on a new one. And I think the best way to do that is to leave a lot of workloads in VMs, right? And stay comfortable with vSphere and vCenter, and then bring in Docker Data Center and Universal Control Plane to manage those containers, and then make decisions about where to run things, you know, down the road. Like, that's the beauty of Docker, right? That's the one thing I didn't even talk about. So why do people care about containers, right? Why do I care? Well, let me go back to this slide. Here's why you care. If you take that host on the left, and let's say it's a Linux host, and let's say that first VM is a Linux VM, I can move those applications between those two Docker hosts and never modify them. I don't ever have to worry about what's running in that VM or on that bare metal. All I need is the Docker engine. So if I write code on my MacBook, right, I can run it on my MacBook using Docker. I can run it in Azure using Docker. I can run it in AWS. I can run it in vSphere. I can run it in bare metal. And the only thing I care about is that the Docker engine is on those hosts. Is it the same operating system family, Linux or Windows? Yes. Is Docker running? Yes. That's all I need to know, because everything I care about for that application is in the container, right? The operating system definition, the libraries and binaries that I need, as well as the application code, right? And things like health checks. That's all built into the container. So I can do a Docker run on my MacBook, it runs. I can do a Docker run in an Azure instance, it runs. I can do a Docker run in an EC2 instance, it runs. If somebody was to come to you tomorrow and say, hey, we're on vSphere today, but we want to try this cloud thing. It sounds super cool, so we're going to do it because it's cool, and I want you to take 1,000 virtual machines and move them into Azure over the weekend, right? That would be really hard. That would be a lot of work. But if they're in Docker containers, it's vastly, vastly simplified, because you don't have to translate that workload. It's already in a portable format. And that's the number one reason that people got started with containers. It doesn't work on my machine. The developer built it. It worked in QA. It didn't work in production because something changed between the binaries and the libraries and the config files and the health checks when you move between those environments. But when you put it in a container, it all is there. And that's the number one benefit, right? And so when you talk about existing skill sets, if you start with your containers in a virtual machine, you can move them into bare metal or into the cloud very easily, right? And that's the key benefit. You don't have to translate them. You don't have to, run them through some sort of converter. They just work. These are just like 5 things to think about. There's probably 500, but these are some to get you started. We're going to drill into each one of these now. So, if you think about virtual machines and containers, most people are running a single workload in their VMs, right? And we're hearing that even in virtualized servers, there's a report that came out from an analyst firm that they're only 40 to 50% utilized, even when they're virtualized. And I think that's because there's some hard things that go into optimization, right? You've got to understand your application at a deep level, right? You've got to basically know that, some people can tell you at a high level, right? They'll classify their apps as CPU intensive, memory intensive, IO intensive, storage intensive, And they'll be like, okay, well, I know that that goes in this sort of one of three profiles of a VM or physical server. I've got a CPU optimized one, I've got a memory optimized one, and I've got sort of a storage optimized one. And they do this sort of high level analysis. Well, that works to a point, but it's not going to get you fully optimized, right? So what we've found in some testing that we have done is that, and what we've seen borne out from customers who are actually making these journeys, is that you can gain some nice benefits simply by moving into a larger VM. So if you've got 8 workloads running each in their own VM, you can take those 8 workloads and make one big VM, right? Make sure it has enough memory and CPU and RAM to accommodate those, the 8 workloads, and put those 8 VMs into containers. So on the left, we've got a hypervisor running 8 separate virtual machines with 8 separate workloads. On the right, we have a hypervisor with one virtual machine that is large, that has been expanded, and it's running that same workload, those same workloads in 8 app containers. And what we find when we do that is you can conservatively, in some cases, get like 25%. You could do that with 25% less compute resources, right? So if you were doing a cluster of 4 servers, you can do the same amount of work on 3 servers, right? There's like a 25% reduction in the resources required, and that's looking primarily at CPU, but you also get savings on storage. That can be in that range of 30%, a little bit less RAM, right? The other thing you'll notice is that on the left, you've got 8 guest operating systems to patch. On the right, you have 1, right? You have that one guest operating system in the VM. And the other thing is you have a reduced data center footprint. You are now managing 25% fewer servers. You're using less cooling. You're using less electricity. You're using less rack space, all of that stuff. So you can keep things in a VM, you can keep those existing workflows, and you can optimize those virtual machines, right? You can optimize the number of VMs you're managing. Oh, and by the way, the golden image for that one VM on the right is the base OS and Docker, right? It's not, you don't have to have 100, and 200, or 50, or 75, or how many golden images you're managing today, because everything you care about is in the container. And you manage that with something called a Docker file, which is a text file that you store in GitHub, so you always know how your containers are built. Makes it vastly, vastly simpler to manage your VM golden images. But what if you want to move out into bare metal, right? What if you want to go and take those VMs and you just don't want a hypervisor? Well, that works too, right? You can take those 8 containers and you can run them on bare metal. And what we found is that can be around 50, 2 to 1, 50% more efficient, right? You can go from a cluster of 4 servers to a cluster of 2 servers, right? And fewer OSs to manage again, right? 8 OSs to 1 OS, no hypervisor in this case, same storage savings, same memory storage, memory savings. Let me take a drink, I'm getting ahead of myself. And a reduced data center footprint. We're seeing customers actually get consolidation ratios upwards of 10 to 1 in some cases 20 to 1. Depending on the workload. But you have to understand the workload. This isn't magic, right? So yes, you should plan for higher densities, right? And you should make a decision on what works for your environment. Do you want to go bare metal? Do you have the tools to provision it? Do you have the workflows to deal with bare metal? Or do you just want to go with fewer, bigger VMs with much simpler master golden images, right? A golden image that is just Windows and Docker, or just Linux and Docker. Right? One golden image for all your applications that have been containerized. But whatever you do, you will need to tune to optimize. You will need to understand your application, right? You will need to have you can't just put it in a container and say, oh, good, now I don't have to think about it. You need to think about it. And we'll talk more about that as we go through. So with that, I am going to just really quickly, let me do something. I want to come over here and I want to see. I was going to pause and see if there was any Q&A, but I seem to have lost that. So I'm going to do all the questions at the end. I was going to do them as we went along, but I'll do them at the end. So if you have a good question, write it down, don't forget it, or put it in the Q&A window and we'll go back. So what about security? What does security mean in the context of containers? It's not just isolation, right? Some things to think about. Right? Do you know where your golden images came from? Do you know that if you walked up to a golden image and deployed it to tomorrow, that it would be the exact same one you deployed today, and that somebody didn't go in there and change it and just keep the same name? How do you know that? How do you know they're up to date? How do you know that you don't have a security vulnerability? How do you know who can access those resources and manage them? And how do you deal with sensitive data and passwords? How many of you have ever put a database password in a script file, right? Or in a shell script or in an environment variable? That's terrible, right? We shouldn't do that, but we do. And all your communication channels secure. How do your VMs communicate with each other? How does your management infrastructure communicate with each other? Is it secured with, TLS? So at Docker, we look at security from the perspective of three things, right? We want usable security. We want basically secure defaults that is tooling that is easy to use and is integrated into the workflow, right? So that if security is hard, if security is difficult, then you won't use it. You will write your password on a sticky note and put it on the side of your monitor. You will put environment variables with passwords into your shell scripts. You will do all of these things that you shouldn't do because it's too hard to do anything else, right? Whatever you need for your application, it's delivered securely. So when you talk about a Docker cluster, it's a swarm cluster is what it's referred to. When we build these clusters of Docker hosts, all the communication between those Docker hosts is encrypted with TLS, and that is set up for you automatically, right? You can encrypt your networks with one simple command line parameter. We will rotate your PKI key or your keys for you, and we'll rotate those certificates for you for that TLS network if you want us to do that. Or if you want to bring in your own infrastructure to manage your certificates, you can do that as well, right? And then we want those security constructs to flow wherever the app goes. So if I define the security, if I define the network, and if I define the application secrets, and I put all that together on my MacBook, I want that to work in Azure. I want that to work on vSphere, and it does, right? Because it's ingrained with the way you define your application. And then, so that's infrastructure independence, and that means safer applications for everybody involved. So what does it mean then, right? So Docker Data Center, Docker Data Center is a tool that ships with Docker Enterprise Edition Standard and Advanced that allows us to manage our container environment. So if you think about vCenter, right, it's equivalent to vCenter only for containers, right? And it does things like work with your application secrets, right? So you can define an application secret, and that will be stored securely in the cluster. And it will only be sent down to nodes in the cluster that actually need that secret to do work. So if I define a secret and I store it in one of my manager nodes in my cluster, and I start up a database, it'll send that securely encrypted over TLS down onto that worker node. It will only be stored in memory on that worker node if you're running Linux, and it was only accessible by that application there. It's a very secure way of delivering things like certificates and passwords and everything else. Image signing and verification and image scanning I'll talk about a little bit in the demo that I'm going to do next. But the idea is that I can sign images. So I actually won't demo this, so let me explain it. You can take a base image, and I'm talking about the base container image, right? And you send that to a developer, and you say, hey, developer, here's a container image that is Linux. I want you to build your application on it, right? Or here's a container image that is Python. And so the developer gets it. He looks at the digital signature, and he says, yes, this was signed by my central IT organization. I can work on this. He adds his code. He signs it. You now have an application image that has been signed by the ops team and by the developer. It goes to QA. QA tests it. They certify it. They say, yes, it passes all of our muster, and we're going to sign it. Now when it gets back to you to put into production, you look at it and you say, this image has not been tampered with. It has digital signatures from the IT team, the development team, and the QA team, and I'm going to put that into production, right? That is something that I am not aware of that you can do at least natively with virtual machines, unless it's happened recently. You know, I never like to say it cannot be done, but I think it's a pretty unique feature. Image scanning we'll look at, but it's basically making sure that your images are always up to date. We talked about encryption at rest and TLS encryption. Of course, users and role-based access control. Docker Data Center integrates with Active Directory or another LDAP directory service, or you can build your own directory of users and groups. Use those things to assign roles and permissions to any object in the Docker universe, so that you can know that only the right people are doing their work. So I'm going to pause, and I'm going to pop out of here, and I'm going to minimize this, and we're going to do a little bit of a demo, right? So let me set this up for you real quick. Sorry, I wanted to come back over here. This is Docker Universal Control Plane, right? So it runs on, in this case, it's running on a cluster of machines in Azure. It could be running on a cluster of virtual machines on vSphere, or actually, this is on AWS. So if I come in here to nodes, you'll see I have 6 nodes here running. If you do any AWS, you'll realize these are AWS internal IPs. I've got 3 manager nodes and 3 worker nodes, right? And so these are AWS machines, instances. They could be physical nodes. They could be virtual machines in vSphere, right? They could be, they could actually be hybrid. You could actually build a cluster where some of the nodes are in Azure, some are in AWS, and some are on your local machine if you wanted to, provided you have all the networking capabilities in there. So you can manage everything through the UI, but you can also manage everything through the command line. So let me make this just a wee bit bigger for you. I made it a wee bit too big because I can't see the bottom of it. So if I do a docker node ls, this is actually the command line on my local MacBook. And I'm telling my MacBook to look at my cluster up in AWS. And you'll notice that these addresses, 132.220, are the same as the addresses here. So you can manage this cluster either from the command line, or you can manage it from the web interface. So let's go ahead and deploy a service. So we're going to create a new service. Actually, we're going to create a stack. A stack is an application. It's made up of multiple services. So how is that defined? You'll get from your developer something called a Docker Compose file. And it basically defines how the application should be deployed. In my application here, I'm deploying 3 services: a web service, a database, and a visualizer. I need one network called backend. So Docker is going to create a software-defined network called backend that will work among my nodes in that cluster. Containers on that network cannot be seen by containers that are not part of that network, right? So there's isolation there. I'm going to deploy 3 copies of the web, 3 copies of the database, and only 1 of the visualizer. And I'm going to use these container images, right? This one is on my private repository. This one I'm pulling from the Docker Hub, which is a public repository. So what is dtr.dockerdemos.com? What is that? Well, that is where we store all of our container images. So DTR Docker Demo, so Docker Data Center is made up of Docker Trusted Registry, or DTR, and Docker Universal Control Plane, UCP. So if I come over here to Docker Trusted Registry and I click on Docker Pets, I can click on the images, right? And so I have multiple versions of this image, of this web service, right? I have the 1.0 image which I'm about to deploy. I have a 2.0 one, and I have one called Broken. Well, what's up over here, right? Well, we actually have an ability in Docker Data Center Advanced to securely scan your container images, right? So you build an image, everything is fine, but we can scan those things as they sit up on your DTR server and alert you to vulnerabilities that have come out since you deployed the application. So in this case, in this right here, in this layer of the container, we have a Mussel vulnerability, and that Mussel vulnerability is critical, and it's actually documented here in this CVE, right? There's actually a libSSH vulnerability and an expat vulnerability as well, right? So we have all of these these vulnerabilities laid out for us. And that scan happens, right? So you'll notice, right, if I go back to that, that repository, this one is broken, right? And then we can set a policy that if you try to deploy this, we actually won't let you deploy it because it's got critical or major security vulnerabilities. You can define that. That'll protect your environment, right? And if you've deployed it, you can continuously scan them so that if something changes between when you initially deployed it and when it was clean and something was discovered as being broken, you can take remediation based on that. So let me come back over here to this Docker Compose file, and I'm going to copy this. I'm going to come back in here, and I'm going to deploy a new stack. So I'm going to call my stack pets. That's my application. And now I'm going to paste in this file, right? And I'm going to click Create. And what you're going to see is that Docker Data Center is going to go out and it's going to deploy 7 different containers, 3 for the web, 3 for the database, and 1 for the visualizer. It created 2 networks, a default network and a back-end network, right? We talked about that. So click Done here. We'll click Pets here. And you'll see, okay, my application is now running. I didn't have it running before. It literally took that little time for my application to start up and be accessible. That's how fast containers start. If I come in here, I can access my application right here at this URL. My application is basically a simple application that lets me vote on my favorite pets, right? So I vote on dogs, and I can serve another pet. Notice up here when I say serve another pet, so it says C26 again up there. Let's say Mike, and I'll vote for Wales. Notice that that is changing. That is because we can do internal load balancing that's built into Docker Data Center to load balance the requests coming in to the various containers providing that service. So this web front end is being backed up by 3 different containers. And so when I vote, any container can respond to that request, and it's load balanced between those ones in the environment. So that environment looks like this, right? So this is the visualizer, and you can see I'm running my pets web containers on this host, and this host. I've got my database on this host and this host. Well, what happens if one of those nodes was to go down, right? So let's look at this. This is the node 260 or 26-12, something like that. So if I come down here and I go to Docker node ls 2612, it's this one right here. I'm going to take this node and I'm going to put it in maintenance mode. So Docker node availability. Update availability. Live demo, folks. Availability equals drain. That's basically saying take all the workloads that are there and shut everything down and put this in maintenance mode. The system is still up. It's just not going to accept workloads. It's not going to let anything run on it. Everything will be stripped off of it. And I will put in that node. I'll put in that node ID. And I forgot something here. -- Oh. Yeah, I did that wrong. Sorry. The -- goes in front of availability. Or, yeah, my bad. Give me a second. Is it Monday? It's Tuesday, right? I need more caffeine. So if I come back over to the visualizer, you'll see that those workloads are not there anymore. But you can also see now that it has restarted the database here already, right? And the Pets Web will start up on one of these as well automatically. There it started Pets Web on this server. So when a failure is detected, we're going to automatically restart those containers, right? In this case, it was a planned downtime, right? We put it in maintenance mode. But if we had gone and that had crashed, the exact same thing would have happened. The other thing is you can put health checks on containers, right? So you can tell a container, you can build a health check into the description of the application. And then it's something simple like, ping this container with HTTP and make sure you get OK back. And if you do, then that's great. The container is healthy. If it's not, mark that container as unhealthy. If the container is marked as unhealthy, then we will take that container offline and restart a new one in its place. So we can do that. Let me see if I remember how to do that. I think if I come over here and I say 5,000, actually I can't remember. There's a way, the guy who wrote this told us how to do the health checks, but I think it is, I can't remember how to do the health checks. So I was trying to go off my demo script, but I'm not going to do it. I was going to try to fail a container for you. So some other things we can do in here. If you wanted to update the Pets Web service, let's say you needed to do a rolling upgrade. I'll come into the service Pets Web, and this is the image for that application, right? I can come in here, and I can say it's time to upgrade this to a new version of Pets Web. And I can come in here, and if I update this to broken, right, that's our broken one. It actually won't deploy. And I click here, and then I come over here to scheduling, and I tell it to do one container at a time and wait 10 seconds between each update. And if something goes wrong, pause, and do not let more than 20% of my containers fail. So what did I just do? Let me go back over that for you. I'm saying when we do these updates, only update a single container at a time. And once you start an update, wait 10 seconds, right? If more than 20% of the upgrades fail, then stop. So that failure is based on the health check. So if something goes wrong in this, then stop and wait for some sort of action. So I'm going to save the changes, and you can see the service is being updated. If I come back to the visualizer, you should see that Pets Web is running here, and it's running here. We've taken one offline, and we're going to update it. So it's really hard to see, but this is tag broken, and it's starting this container up. What's going to happen is this is going to fail, and then it's going to pause the update, right? And so I can come back over here and, excuse me. Oh, the health check did work, right? It's right there. It came back as okay. So if I come back over here, and we'll come back and visit this in a bit, but what's going to happen is that it's going to eventually fail, and it's going to pause. So it says update in progress. Once the health check fails 3 times and it realizes it can't deploy that container, it's going to, that'll be more than, it'll be, right, so unhealthy container, so it's going to do that a couple of times, and then it say paused. Okay, the update has failed. What am I going to do? Well, I can continue the update, or I can come over here and I can say rollback. If I click rollback, it's going into the update. If I go back to the visualizer so we can see what's going on, that container is gone. It'll start up a new one in its place, and that will be deploying back to the last known good version, which is 1.0. So really hard to see on your screen, but right there that says tag 1.0 instead of tag broken. So that is how you would go through and remediate a failed update. It's also, you know, if I did this one more time, and I think that it should be about done updating. It still says the update's in progress. So if I wanted to go in and upgrade to a good version, I would just change this to 2.0, do the upgrade, and we'd go. But we're running short on time, so I'm going to get back to my slides. That was just a quick demo of Docker Data Center. You saw us deploy an application. You saw us simulate a failure of a node. You saw us do an upgrade that failed, and then we rolled back to a known good version. And then just for giggles, we'll come back and visit this after I get through the rest of my slides. I'll do this 2.0 upgrade, which is a good upgrade. Upgrade to 2.0, click check, and it will start doing an upgrade here. We'll say, again, 1. We'll say 10 seconds, and we'll set the failure ratio to 20%, and we'll say save changes, and it will go out and it will update. But let's get back to the slides because we're running late, and I want to get through the rest of them. There's not very many of them. I'm probably going to skip the next demo because it's not very exciting anyway. So, all right. So leveraging existing skill sets. This means we believe we should meet the teams where they live. So we have versions of Docker for your developers that run on Mac, it runs on Windows, and it runs on Linux, right? These are for the Docker for Mac, Docker for Windows are for the developer desktop. So, right, we have native Windows containers running on Windows Server 2016, but we also have this tool called Docker for Windows, which lets you develop both Linux and Windows containers using virtual machine technology on a Windows 10 desktop. So you can run a Linux VM, develop a Linux container on your Windows desktop, and then deploy that onto a Linux VM running in Azure or vSphere or wherever. If you're an operations person and you want to use AWS or Azure, we have additions for that as well. And that allows you to build that Docker data center installation with just a few clicks through a CloudFormation template. And then we integrate it with things like CloudWatch logs, right? So all your logs go into CloudWatch, and all of your hosts are part of an auto-scaling group. And so you can automatically auto-scale the number of Docker hosts and expand your cluster size using auto-scaling groups, right? So we want to bring Docker into your environment in a way that makes sense for you, right? So use CloudFormation deploy Docker Data Center Enterprise Edition, use auto-scaling groups to scale out your infrastructure, use CloudWatch logs to aggregate your logs, and we'll use Amazon Load Balancers to front-end all of your nodes so that you can always be assured that requests for your applications are being routed correctly from the outside, right? We talked about an internal load balancer, but this is an external load balancer. I'm not going to do this demo for Docker for AWS because it's really pretty straightforward, and we're running out of time, and I got to leave time for questions. Real fast, a couple more slides. So you don't have to start with microservices. A lot of people talk about having to do, oh, I can't go to containers because I don't want to do microservices. Well, that's just one way of doing it. Most people are actually doing something that we call migrating traditional applications, right? So we have an offering right now, a joint offering with Microsoft, where we're going out and we're working with customers to take Windows applications that are in a VM and move them into a container. And customers have been wildly successful with this. It's in the early stages, but we've had a bunch of really big name customers. MetLife was on stage at DockerCon talking about this, where they have taken applications in production into a container, off of a Windows VM into a Windows container running on a Windows platform. Once you get it in there, you can start breaking it apart, right? So if you have an application, you can start breaking it apart. Maybe you leave the database in a VM. You don't touch the database, right? Because that's a little more complicated, right? Maybe you move the web front end into a container, and then you move the authentication module into a container, and then you move the catalog lookup into a container, right? And you break that down slowly over time. That's what customers are doing. They're doing 1 and 2. Many are doing 3 as well, but we're seeing a lot of traction with 1 because we've already talked about just moving into a container gives you efficiencies. So there was a lot of great sessions from customers at DockerCon this year, all of which are up on YouTube. But they basically came back with some key cultural learnings, things that you need to do if you want to be successful, right? So if you're looking at rolling out containers in your environment, do not do this in a vacuum. It's not just about the dev team and the operations team. Get the security team involved. Get the exec sponsor involved. Get your performance team involved, right? You need to have all of that, all of those people working together to be successful. Choose the right partners. There are consultant partners out there, Booz Allen, Avanade, lots of regional partners who are doing this every day with customers. If you want to go with somebody who's had success, choose the right partner, right? Define your guardrails. Don't try to boil the ocean. Leave the database alone. Focus on the web front end, right? Pick one problem you're trying to solve. Focus on that. You're going to make mistakes, so be flexible, or flexible, right? I guess I misspelled that. It's bound to happen, right? But don't be afraid of it. And know that when you go into it, you're going to think one thing, and it's going to probably come out being something different. But the beauty of Docker is that if you decide that you wanted to do it on a VM, but really it should be on bare metal, that's easy. or you put it on bare metal and you don't have the consolidation ratio, you're not driving utilization the way you wish you could, put it in a VM on a server with a bunch of other workloads, right? But whatever you're doing, sweat the small stuff. There's things called labels, for instance. You can label everything in Docker, and those labels can be used later down the road to make your life way easier. You can label something as AWS or Azure as vSphere, right? So this container runs on vSphere. It's labeled vSphere, and it's on a server that has SSD. It's labeled SSD, and it's in the Portland data center. It's labeled Portland. And later, when you're looking for stuff, you can filter based on those labels, or you can tell application containers to only deploy to certain nodes based on those labels. Only put this container on a host in the Portland data center with SSD. Only put this workload on Azure on a T2 instance. Or excuse me, I mixed my metaphors there. On Azure, on a D1 instance, right? Sweat the small stuff. Label everything. Think about all those details. Pick the right project. Start small. If it's greenfield or that is another error. If you want to migrate a traditional app or you want to go microservices, totally your call. But pick something manageable to start with. Think about the things that trip people up. Port mappings. We didn't talk about it, but they can be problematic because you can only expose port 5000 on a Docker host one time. So if you have an application that you need multiple instances of and the port mappings are statically mapped, how are you going to deal with that? How are you going to move information from your test environment to your dev environment, from production to dev, from the developer's workshop, all these environments? How do you pass configs around to do that? What do you do with persistent data? We talked about the database. These problems are all solvable. There's people today, we've got hundreds of customers, thousands of customers probably, running databases in production with Docker. That's not a problem, right? It can be done. You're going to have to change your processes, though, right? You can't just say, I moved it into a VM and I'm leaving it alone, right? Because you don't back up containers the way you back up VMs, right? You don't scale containers the way you scale VMs. You don't size containers the way you size VMs. You will need to develop and refine and adapt those processes, adopt them. But, go forward, be fearless, go do it. Like, go out and try something. So what should you do next? You should go out and test drive the tech using our hands-on labs. So if you go to github.com/docker/labs, there's a bunch of hands-on labs there that you can try. There are some great customer sessions from Visa, ADP, Intuit, Northern Trust, all on YouTube from DockerCon. Find the DockerCon 2017 playlist and find those sessions. They will tell you what real customers have done in real-world situations, right? Not just my sort of high-level examples, which were taken from these sessions, but really concrete examples about, did they go bare metal? Did they go VM? What were the consolidation ratios? How did they work with the security team? What did they screw up on, and how did they recover? Pick a pilot project and get your hands dirty. Even if it's just you taking something that you run in production and putting it over here on a little test network in your Skunkworks project, just go do it. Like, try it. And then share your knowledge and your missteps. Join a Docker meetup in your city. Write a blog and send it over to us via Twitter, and so we can share it with the rest of the world, right? Let people know the bumps in the road that you hit, because there will be bumps in the road. This is new technology, and people are using it every day, and every day we're learning something. Share that knowledge. Again, you can follow me. You can tweet at me at Mike G. Coleman on Twitter. But with that, that wraps up the slides, gives us about 5 minutes for questions. So let me come out of here, stop sharing, and we're going to come down here in the QA. And
yeah, we have there's a whole bunch of questions in there for you, Mike.
Yeah, I see
Q&A. Are you able to see them?
Yeah, I do. I probably won't get to them, but I'm gonna take them as fast as I can. My question is, I am planning an app CIMS, and I want to use Docker. What cloud would you recommend? GCP, Azure, AWS under my belt, TCO performance. I don't know, right? I'm not intimately familiar with those platforms from a cost perspective. I think you're going to need to do some research on that, or a performance perspective. The thing is that I will say to you, though, is if you put it in Docker and you choose one of those platforms and it's not meeting your needs, super easy to move. Like, that's one of the benefits of Docker. We don't lock you in. So if you go with GCP or Azure and you use Docker Data Center on Azure, you can use Docker Data Center on AWS, and you can just move your workloads over there without ever modifying them. Much less work than if you make that. Oh, sorry, I thought I had. And then if you did that all in sort of native VMs on those platforms. What's the max size of a container? As big as you want it to be, as big as the host can handle. There's no max size, but you can tell a container that you can define container resources around a couple of different parameters. One is, what is the minimum size that I need for that container to start? So I need at least a gig of RAM. If I don't have a gig of RAM, don't start the container because it won't even run. And don't ever use more than 2 gigs of RAM, right? So limit that container's memory. So what's the amount I need to reserve, and what's the limit for me? But the size of the container is as big as you want it to be. So it's impossible to run a Ubuntu container in a Windows host running a Docker engine. Yes. You cannot run Linux containers on Windows natively. You have to put them in a VM. If you want to run Windows containers on Linux host, that Linux host needs to be running KVM. If you want to run Linux hosts on Windows, those Windows hosts need to be using Hyper-V, right? Or you can do it in ESX, of course, right? So yeah, that there. You know, we're not, do we have a reserve? Yeah, there we go. Do we have a reserve system resources for each container? Is that shared? Talked about that just now. Yeah, this is such a great question. I should have covered it. Can Docker Data Center run both Windows and Linux workloads? Absolutely. My cluster was all Linux, but you can do Linux and Windows workloads. And I'm actually been touring the country doing a workshop on this. I will be in New York on the 17th of July, in Boston on the 18th of July. I will be in Seattle sometime in the month of July. If you're in those cities, check it out. The repo, github.com/MikeGColeman/hybrid workshop. I will tweet that out after this presentation. You can run it yourself if you want to. Yeah, does Docker have a tool for image scanning? I showed that. Does the hypervisor recommended to allow hosts to be clustered? No, you can use Swarm to cluster bare metal. You can use Swarm to cluster VMs, right? So, but know that like resource pools and resource sharing is much more sophisticated in vSphere than it is with Swarm today. So that is something to consider. That's another reason to stay with VMs. So you would set up a vSphere cluster, and then you could set up a bunch of VMs, and then you would cluster those with Swarm. 2 levels of clustering. TLS 1.2, latest version. What version of TLS? So the scanning capability is part of Docker Data Center Advanced. Someone said, is that securely scanning an image is the registry done by a component that is part of Docker Data Center? Yes, it's Docker Data Center Advanced. The file that I mentioned was actually, someone says, is that the Docker file that you mentioned? No, I mentioned the Docker Compose file. You can also get the Docker file if you want to build the images yourself. You can get a Docker file and a Docker Compose file. Docker Compose file defines the application, which is made up of multiple images. A Docker file defines a single image. I want to start testing DDC. Is there a test version? Do Docker for Azure, AWS use DDC under the hood? So there are. So this is going to be my last question I answer because we're running out of time. But I will take the rest of the questions. I will answer them offline, and I'll post them responses as a blog post. So I will do that for you. So you will get your questions answered. It'll be via the blog. But this last question, there is Docker Commercial Community Edition for AWS and Docker Enterprise Edition for AWS and Azure. And Docker Enterprise Edition for AWS and Azure includes Docker Data Center. And yes, there's a 30-day free trial for Docker Data Center. So you can download a free license. You can deploy that up in Azure or in AWS using Docker EE for AWS or Docker EE for Docker Azure. Sorry, I was a little bit wordy today, so we're over by 1 minute, but I certainly appreciate you all attending. I will answer all of your questions via a blog post. Expect that to go up hopefully in the next day or so, because I'm going on vacation for 4th of July. So I'll get that started today. With that, thank you so much for attending. Session will be recorded, so you can share it with your friends. Tweet at me, at Mike G. Coleman. Follow at Docker for the latest information. Have a great day.
Thank you so much, Mike. This does conclude the webinar, everyone. A reminder, the session was recorded and a copy will be sent out to you. And please be sure to register for upcoming Docker webinars at docker.com/webinars and check out docker.com/events for customer-facing webinars and events. Thank you again for joining us and have a terrific day.